Okay, so my name is Angel. I'm going to be presenting to you the two stages that were included inside the project that we were working on. I'm going to start with the execution stage. This stage is mainly to perform the arithmetic logic and address computation based on the decoded instruction. This stage has some of the modules that Some of the modules that include this stage are ALU control unit, multiplexers, branch comparator, forwarding unit, and the pipeline register. So to understand a little bit more about this process, I'm going to be talking about how this works. So we're going to be considering the instruction additional for explanation purposes. We're going to be using this operation, and this operation requires three registers. These registers names are R1, R2, and R3. This stage calculates the sum of the values of the R1, the R2 and the R3. So what happens inside the execution is that the values registers the result is stored temporarily and passed through the pipeline stage, usually the memory or directly to the write back stage. This depends on the design. I'm going to move my page here just to tell more about challenges that may encounter during the execution of this stage, which could be the handling of a floating point operation and mitigating the branch mispredictions. These kind of problems are more often than I could like to happen here. So this is some of the designs, some of the schematics that were used inside and the results of the output from this execution stage. So now we're going to be talking about the pipeline stage, which is called the write-back stage. The write-back stage is its job is to process the result and writes in a memory load to the register file by selecting the appropriate data through a multiplexer based on the instruction type, using the write address and control signals. To do so, we have including some of the modules are shown here, the multiplexer, the register files, and branch prediction. So to understand the write-back in pipeline and register, I'm going to be talking about some of these concepts, not all of them. The function of the write-back is to ensure that the ALU memory, the results that the ALU memory give us are perfectly and accurately written to the register file for a future use. The write-back logic determines where the results from the ALU or the memory should be stored in the registers, and the register file updates the register with the final computation values. This is crucial for the correct execution of the subsequent instructions. The testing components are utilized, test benches are utilized to verify each pipeline component's functionality and performance. Give me a second here. Okay. The pipeline simulation simulates the execution order of the instructions to ensure the proper operation. I'm going to skip this. Some of the challenge on the write back stage are ensuring that the data is accurate accurately stored, and sometimes the troubleshooting pipeline hazards or incorrect values that are received inside our program or our execution of the writing back stage. So it is not that complicated. We got the output of the schematic, some of the modules that we previously mentioned, the multiplexers, the register files, and the branch prediction unit. And here are some of the outputs. Okay,